Hello, I recently made a short video about how to switch current from any e-bike display, and I said I'd make a follow-up proper video, and I didn't think I was going to get around to it. So here it is. Anyway, first a couple of points. Your wiring on your typical screen really doesn't support much in the way of current. Like this looks like 26 AWG, so it might support an amp, but I swear I've seen 28 or even what looked like 30 AWG, which doesn't support anything. And the other thing is, if your lights output on your controller becomes active when you turn the screen on, then your blue wire from your screen just connects to a pad on the inside of the controller, which the red wire on your lighting output also connects to. So any current you draw through your lights is just passing through the screen. And as a side note, the UKC1 screen, in the instructions, in the specifications, it says max output current to controller 100 milliamps, which is somewhere between 6 and 8 watts depending on your battery state. And I have to say right now, I think in terms of 72 volt bikes. So this relay is a 72 volt relay, and it's a JD2912, and that's a 40 amp relay, but they do come in a wide range of flavors. I'm pretty sure you can get this 72 volt or a 60 volt or a 48 volt. So if you've got a 60 volt bike, then look for the 60 volt, and if you've got a 48 or 52 volt bike, look for the 48 volt. I did make up a 96 volt twin relay, which I've been able to pull the relay, the coil sequentially off a 72 volt battery, which is obviously great if you need a circuit switched one before the other. So part of the reason I delayed this is because I just wanted to come up with the best way of doing things before I do a total rewire of my bike. And this is what I've come up with, because the controller on my bike actually does support the lights on instruction from the screen. So I can turn my lights on with the lights on function, and I want to be able to switch current with the screen on function. So in conjunction with this relay, I have used a 1N4937 diode, which is just a got a faster recovery time than the 1500 billionths of a second that the 1N4007 has. And I've got one here to show you. Hopefully you can now see the silver band on the right hand side of the diode, which denotes the cathode. So what I've done is, when I'm ruggedizing these, I literally solder a black wire to this leg and a red wire to this leg, and then cover the whole thing in heat shrink, and I know from the wire color which is which. So much as I've made this up, I haven't quite finished this bit, just to demonstrate that in here, this is our power feed to the coil, and this is the diode, and I've wired the anode of the diode to the negative. And it's better to not include the diode than to wire it the wrong way around, so you have to be competent about what you're doing. Feel free to ask questions in the comments, and if you want to see a complete build of something like this, put it in the comments and I will do it next time I make one of these up. So I've just got a piece of heat shrink here to cover this lot up. I typically glue these pins with Glashevsky, which is just contact adhesive. But I have yet to have a problem with dodgy connections sort of following this sort of technique. And the other thing is, you can actually test that you've done your relay, your diode correctly. With a continuity tester. So if I connect red to red and black to black, we can't conduct. But if I connect it back to front, we're showing the resistance of the diode. And the reason for the diode is when a relay coil is de-energized, the collapse of the electromagnetic field creates a voltage spike, and the diode just gives it somewhere to go that isn't the semiconductor switch inside your display. It's as simple as that. But I have done this sort of stuff without using diodes and got away with it, but I have now taken to just using a diode. But be 100% correct in your polarity, and I've just shown you how to test it with a multimeter. So the other thing I came up with is this tiny little wiring adapter, and I've also popped the blue wire and the black wire out of the screen connector, and I'm going to have to bring it all over. So there's the screen connector from the controller side, because I decided it's neater because you have to thread the display cable. And here is those two pins, or should I say there are, inserted in a empty housing. And then this is essentially a male to two female splitter, but it's kind of wired slightly differently. So this is going to be taking the blue wire to the controller and the black wire from the controller, and then these two just male pins have to go back in this housing, and obviously you've got to get them in the right order, and you can just use your screen to double check. And I believe my red wire should go next to the other red wire. Looks about right, doesn't it?
So, I think I'm going to try and put these in from underneath, so it's all neater. Oh yeah, removing these pins. Can I do this? I'm not sure I can. Obviously I'm going to edit the crap out of this and upload it overnight, because I've got to get up at 5 for work, and it's about 11 now. So, that's one home. And that is the other. So,
that is now a really neat new power on output, and it will actually sit down a little bit neater again probably. Right, I'm just going to stop this for a minute and have a reshuffle. Popping pins out of these plugs, I use a small removal tool, but the smallest flat bladed watchmaker's screwdriver is the best thing I've found, in fact, for this size of plugs that we get on e-bikes. And I use this for the relay spades, because I just don't like the inflexible kind of automotive cable. So I've wired all this up. I haven't even tested it. I've literally just crossing my fingers. This is a really old SW900, which I actually like because it switches this really fast. even though the best thing I put this on was the NFC version because it's completely instant. But yeah, really fingers crossed, I guess. Right, I've turned the battery on. Fingers crossed, even though this light is going to be yellow. No issues whatsoever. That's good. Let's just change this color. So any questions, please put them in the comments and I'll get on them straight away. I hope that's helped some of you out. One last thing, if you're on a different protocol, you might have different screen color wiring. It's on you to find your positive output from the screen and your negative. I'm pretty sure your negative is going to be black, but your screen out might be a different color if you're on a KT controller. And obviously if your controller switches your screen on, then you're in a different boat, which is called a motorbike. Anyway, all the best. Thanks for watching. Bye.